Hello and welcome to today's math lesson. Today we are covering Chapter 8, Lesson 4, and we've been talking about similar figures, similar triangles. And we've just recently talked about proving two triangles are similar by angle-angle similarity. And then we just added side-side-side similarity and side-angle-side similarity to our repertoire. All right, today we're going to be talking about more proportionality theorems that can be used within the triangle. So let's look at this triangle QRS, and then we have a segment in here TU, and we're saying TU is parallel to this side. Now, we've had mid-segment theorems in triangles before, but this TU is not necessarily the midpoint. RT is not congruent to TQ. So this is not a midpoint. So what they're saying here is if we have two sides in a triangle that are parallel, it is going to divide the corresponding sides proportionally. So x over y is going to be the same thing as s over t. Okay, the sides will be divided proportionally. So x over y is going to be the same thing as s over t. Likewise, the converse is also true. So if we say this backwards, so if I have a triangle with this line in here, and I have x, y, m, and j, and I'm telling you that x over y is proportional to m over j, then what can we conclude? We can conclude that AB is parallel to CD. We can conclude that AB must be parallel to CD. So if the ratios are proportional, we can conclude that these two segments must now be parallel. All right, so the converse. So if it divides it proportionally, then we can conclude that these two must be parallel. All right, so what are they telling us here? We have a triangle. We know that they are parallel. So we know that this segment compared to this one, 44 over 35, must be proportional to 36 over what? Okay, and if I call this my what? So we're going to cross multiply. So we're going to take 35 times 36 and divide by 44, and that's going to get us our x value. And I think if I did my math right here, if we round to the nearest tenth, it's 28.6 is going to be the length of YZ. Now, not everyone sets up their proportions the same, so somebody might set up 35 over what is 44 over 36. No matter which way you're doing it, do you see how you're still multiplying 35 over 36? You have to just do things in the same order. I went top to bottom, or I went the right side to the bottom side, the right side to the bottom side. You have to do it the same way. All right, so now what this one's saying is if we just have two lines L and M, and if we have lines dividing here, and we're telling you that all of these blue lines are parallel, every piece is going to be divided in the same ratio if you're comparing the same piece. So you can't compare this piece to this piece because they're not the same ones, but between the two, we can compare this piece to that piece. Those two must be in the same proportion as any other ones that we would be doing. So what do we have here? Single mark, single mark, single mark, and it's all in the same line. So that would be saying corresponding angles are congruent, which now makes this line parallel to this line. Likewise here, if we now know that these are all parallel lines, if this one's 90 degrees, then this has to be 90 degrees, and that has to be 90 degrees. So what they want us to find is what the length is from H all the way to F. So what can we set up? Well, there's a lot of different ratios. The first one I'm going to set up is 120 to 150. Okay, 120 to 150 must be the same as this piece to this piece because they're divided proportionally. So GH to 300. Now, many of you can see that's 150 times 2 gives me 300. So I have to do the same thing here. So GH is going to be 240. So then we can put 240 down here. So 120 plus 240 is going to be 360, and that's going to be the length of your HF. Now, certainly you could have cross-multiplied here and taken 120 times 300 and then divided by 150. Either way you do it, you're going to end up with 240 as your answer for GH. All right, usually kids have a good handle on those things. This is the thing that's completely new, so you might want to just stop the video, get this copy down. This is the one thing that's new that is not intuitive for kids. So it's just not something that you just look at and see, and it absolutely makes sense. So we've done something before when we've had this angle bisector in here, so that this is bisecting this angle. And we did things about, well, this, if I pick a point and mark the distance, remember distance has to be perpendicular, then these two lengths are going to be congruent. So that's what we have worked on before. But what happens in this triangle is anytime you have a triangle and you have this angle bisector, what happens is it divides each separate triangle proportionally. So what I usually do is take the side of the triangle over the short part. So I always do this side of the triangle over the short part is going to be proportional to whatever this side is over this short part. Now, the book always sets it up a little bit different, but it doesn't really matter because when we cross multiply, it's the same thing. I will always set mine up this way. This is the way my brain does it. This is the way it just makes sense for me to remember how to do this. So the book may set these up just a little bit different, but again, when we cross multiply, they're going to be the same thing. So they do the two parts, AD and BD, and then you have to make sure that you do AC over CB. So make sure you do them in the same. So they started at the top triangle. So this goes from the top triangle to the bottom triangle, the two short pieces, back to the top triangle, and this is the bottom triangle, the two sides of the triangle. Okay, so let's set one up and see what we have to do here. So solve for x. Okay, I always like to do a side of the triangle is 7 over its short part, which is QR. Now, how long is QR? If this whole thing is 15, what is x? Well, if I told you this was 2, you guys would take 15 minus 2 and you'd tell me this is 13. If I told you this is 12, you'd do 15 minus 12 and you would get just 3. But now we have a letter in here, so how do we do it if there is a letter in here? Well, you do the same thing. You took the whole thing, 15 minus 2, and said 13, so we're going to do the same thing. 15 minus that piece is x. So this QR is 15 minus x. So I did the side of the triangle over its little part, and I'm going to set that equal to the side of the triangle, 13 over its little part, which is x. And now you guys know how to solve a proportion, so we're going to cross multiply. So 7x equals 13 times 15 minus x. So 7x equals, and 13 times 15 is 195 minus 13x. So now I'm going to add 13x to both sides. So 20x equals 195. And now when we divide by 20, x comes out to be 9.75. Okay, now there's absolutely other ways to set this up. Some people are going to set up 15 minus x over x and then 7 over 13. I believe that's the way the book says it. But look, when we cross multiply, do we still take 7 times x? So as long as you're keeping things in their proper place according to how you set up the first one, then you will be good to go. All right, we are ready for homework time. So the big thing here is in a triangle, when they give you this angle bisector, we set up this side, let's call it X, Y, W, and M. You need to set, if this is an angle bisector, it's going to take a side of the triangle over this part divided Y equals the side of the triangle M over its divided part W, and then we solve it by cross multiplying. All right, good luck on your homework.